Hello and welcome to the YouTube channel D Creations Resources. Let us talk about magnetism and classification of materials with respect to their magnetic properties. So, the origin of magnetism lies in the orbital and spin motions of electrons and how the electrons interact with one another. Historically, the first magnetic material that was observed was magnetite or lodestone, and it was observed that pieces of iron were attracted towards it. If a piece of lodestone was suspended, it stabilized itself in a certain direction. So we know that iron has always had a special role when it concerns magnetism. Now, in technical language, it is called a ferromagnetic material. So, on the basis of magnetic behavior of materials, they can be classified into five major groups: diamagnetism, or the phenomenon is diamagnetism, and the materials are diamagnetic, paramagnetic, ferromagnetic, ferrimagnetic, and antiferromagnetic. Let's begin by talking about diamagnetic materials. These are slightly repelled by a magnetic field, and diamagnetic materials do not retain the magnetic properties when the external field is removed. Now, these materials have all paired electrons, and due to that, they have no permanent net magnetic moment per atom. Under the influence of an external magnetic field, there is realignment of the electron orbits, and hence the diamagnetic properties are observed. And many elements in the periodic table, such as copper or gold or silver, are all diamagnetic. In terms of the magnetic susceptibility, diamagnetic materials have a very weak and negative susceptibility. So, when a diamagnetic material is placed in an external magnetic field, it gets weakly magnetized in the direction opposite to that of the external field. The magnetic susceptibility of these materials is independent of temperature. The relative permeability of diamagnetic materials is slightly less than unity. Super paramagnets are a special subclass of diamagnets. In fact, they are perfect diamagnets and their magnetic susceptibility is -1. We had earlier mentioned the examples of diamagnetic materials as copper and gold and silver. Similarly, even silicon, germanium, diamond, or ionic solids like alkali halides are all examples of diamagnetic materials, and in fact you would notice that they have even number of electrons. Now, superconductors, which were mentioned earlier as the perfect diamagnetic materials, can be levitated in presence of external strong magnetic field. So this is called Meissner effect. Even materials in our daily lives like wood, water, glass are all diamagnetic materials. Now we know that electrons in an atom are revolving around the nucleus, and so due to this they possess orbital angular momentum. The resultant magnetic momentum in an atom of the diamagnetic material is zero. So there are no atomic dipoles as all the electrons are paired. Now, when an external magnetic field is applied, the dipoles are induced in the diamagnetic materials, but they are induced in such a way that they oppose the external magnetic field. So, this is the Lenz's law. And that's why all the materials whose atoms contain paired electrons show diamagnetic properties. The diamagnetic materials are independent of temperature and they don't obey Curie's law. Since the diamagnetic susceptibility is independent of temperature, heating a diamagnetic material will not change its diamagnetic susceptibility. So, in short, the susceptibility of a diamagnetic material is negative. That means the magnetization decreases as the external magnetic field is increased. And since materials with paired electrons show diamagnetic behavior, all the noble gases or all the diatomic gases are going to be diamagnetic, because you can make out that electrons are pairing up in these. And when they pair up in the molecular orbitals, there is no net magnetic moment.